All right. So let's start with the see where ah, what? Wait a minute. I have a total blackout. I would, so I promised to give you a short introduction to rapid prototyping. So Oli, you have been doing some prototypes about a few years ago. Actually, we had a need for doing a set of or a slideshow for one of these three UAS projects. That was basically the first one. We had a 2-week project, student project, with where this stakeholder was actually Lapinjärvi, and basically they gave us very loose project topic of finding out some new ideas how to help these how to help building this memory friendly village. Okay, and for that we actually you thought about, okay, let's try to use this strategic alliance with Laurea and Haaga-Helia as an engine for this one. So we organized a this 3 UAS project, which is now actually happening every year. I think it's on the spring semester at the April, May, somewhere there, and which basically means that students were not only from different disciplines but also from different learning cultures. And for that, we were expecting to have projects which are basically which may have some technology there, but also could be on, just these social innovations. Most of the innovations that came out had some technical parts of it. Every single group was able to also benefit from the fact that there was a engineering student there on the group. But anyhow, Ulla Cederlöf is my dear colleague here. She's teaching mostly this, all sorts of project work and also game programming and such like that. Okay, here's a definition that both me and Ulla are agreeing on. What is the prototype? Prototype is an experimental model of your idea or concept. Very general idea. And also, okay, it's not just for showing the idea, but it basically helps quickly visualize and test if your idea is good or not, or service, application, device, whatever you are designing. In this case, it will be if your innovation idea that you are working on is feasible. And there are a few of these bullet points here, and the top one is probably the most important idea behind the prototype, that it makes your ideas and thoughts tangible. When you have your ideas on your head on the paper, it's still quite abstract, so it's high abstraction level. It's hard to tell anyone or just an ordinary person from street what is this all about. But basically, after making the first or zero prototype, then your thoughts are there, okay, and then you can start testing. And yeah, you can show it to your stakeholder. Stakeholder, they are capable of seeing in the idea, able to, and then okay, now say on software development, especially mobile software development and say Google Word, that kind of stuff, where the users are co-developers, want it or not, meaning test users. So basically that's why our phones feel like they are prototypes. Since the feedback from the customer is always used to develop it further. But that will be a high-end prototype. And then, okay, with prototypes it's easy to see if some ideas just don't work. It may sound good when you are speaking it to your team, and it may sound really fancy, and then you start doing the prototypes, you see, oh, okay, there is a requirement of actually having the platinum surface on this device to that it would actually work. Sounds expensive. Scrap it. Okay. Prototyping overall should be easy, efficient, and fast. And it also helps you on the development process itself. Some tangible prototypes. I should have actually taken this one. So let's start from that one. So basically this is a prototype made on a 3D design program, and that's the 3D printed version. So it's a mobile phone stand. Looks nice, kind of, sort of. And doesn't elephant bring luck? I think, yeah. At least in India, it means that it brings luck if you have an elephant on your family. Well, okay. Then this one is my own hobby. I do actually my favorite hobby is fishing, and basically that's my different prototypes. That's actually the first prototype I have done on this. This is electronic lure, so it has some electronics inside of it. It has a printed circuit board with some electronics and batteries and such kind of things. And this is the 3D modeling part. I also used some other programs to design and develop the electronics for it, and basically these programs work together, so I can check if my printed circuit board actually fits into that one without ordering or making any prototyping printed circuit boards. And well, that's what came out. It was pretty crappy, but on the other hand, it was really good prototype, since now I know how to do the next step, how to make sure that this is actually it's easier to then print. There are some issues on my design that actually are not good for 3D printing. Okay. Currently, it looks totally different. Yeah, but first prototype, that was fast kind of thing. Okay, one problem is on. Okay, this is the surface of the 3D printer. You can produce pieces which are, of course, vertical, and then it can taper here up to 45-degree negative angle. Since if you try to print something like this, you need supporting structures. And the first prototype I had actually had these supporting structures here done with another the kind of water soluble plastic. Okay, but appears that you have to actually soak it on water for more than 24 hours to actually clean it off. It's not fast prototyping anymore. So, but better, the current prototype doesn't have any of these kind of things. So it has maximum that minus 45-degree hanging edges. And it looks different, so lure doesn't need to be nice and round and oval shape. It works better if it has rough edges. Hmm? Yeah, that one I have got a lot of fish actually. Doesn't look like that anymore. the pipes are actually quite attracted to that kind of lure. The not since the electronics, it has lights, yes, but who doesn't? Well, most people don't have any lights on the lures, but but it also have this the cell phone vibrator inside of it, and goes and gives the this kind of bursts once in a while, kind of sporadic rate. Yes, you have a question? I'll go on that one later. Okay, but yeah, mainly software. These are actual design, the first, the prototype, pen and paper prototype for the this system, and a software based, well, a software product, and then it's a paper prototype, and then there's an app. So you use pen and paper, much faster than writing code. On software, you use also lots of mockups, meaning you have the function, a real function, but it's empty or does something hard coded on it. It actually might work in your case. In your case, I would guess you could also use the so-called use cases as a prototype, pen and paper. So use cases, I would guess. Yeah, don't listen too much to the customer here. Remember, okay, I have been out of the real work for 20 years. So I haven't been doing real work for 20 years, just teaching. Okay, about the same. Word has changed. Yeah. Old geeks. Yeah. But he knows a lot, yes, and he's absolutely brilliant teacher for the for this embedded systems programming, no doubt about it. Um, you might actually sometime ask why he actually left the industry, if he hasn't opened up yet. Okay, so more things like, well, there's also the so-called empathy-based prototyping. Basically, this works pretty well for products that are targeted into the consumer market, since there you try to basically make the specifications of quick fast prototype, the specifications that you think actually the users would like to have, not necessarily need. If anyone would have asked about, let's see, almost 30 years ago, if people actually would need SMS, It was just one programming engineer's, software engineer's idea. Well, let's add this one and see if somebody uses it. And then there's also because of not all of the Nokia, the managers at that time were not bean counters yet. They said, oh, well, why not? If you try to do the same thing now in, say, this kind of strictly controlled working environment, there was no, it adds some extra costs. But that was, you just throw it in and people figured out a use for it. All right, and actually it also changed the word. I don't know if it was changed for better or. Okay. This basically is just some specific things. So plenty of the different tools available. So basically this kind of tools are specially designed or specially working well with the service design. Software is one sort of service. So basically you may want to take a look at that source for what kind of prototype you can use for software, since it is software as it's a service. The system provides a service to somebody. In this case, it's the whoever is programming the system. So yes, there's the use cases is marked as one of the tool. Okay, role plays, group sketching, system map, affinity diagram, all sorts of ways to visualize your idea and test the feasibility in quick way. Okay, some concepts. So what is the low fidelity and what is the high fidelity prototype? Well, its illustration is pretty good actually. Sketch is a low. When you just have that's a sketch. Next step would be I would go to the drawing board and or some program and start doing this one and make illustration. That will be the low-fi, and then the high-fi prototype would be basically using 3D modeling to show the same thing, and maybe some animations and such kind of thing. So, okay, wireframes. So Sketch is basically the wireframe kind of prototype. Then there's mock-up. Okay, software engineering, basically software design or fast prototyping is based on the mock-ups, meaning that you have the main functionality hard-coded in your routine that is not necessarily needed yet, but you need the output of that routine. When you are implementing this, let's see some of these real-time operating system ideas, you would start with the mock-ups. Right there, this core of the operating system, but fill it with just function prototypes that either do nothing or return some, do something specific hard-coded, and then define it deeper and deeper and for the details. So how to implement a task scheduler, for example. You just don't start just coding. Hopefully not. You need to have the algorithm. Yeah, you need to have the algorithm. write the algorithm actually first as just comment lines on your code. You just have the comment lines and then start filling what is inside the concept. Otherwise, you get cheese and macaroni on your code. Yeah. So basically, if you are a highly skilled and experienced the expert on any topic, usually the problem is that they are thinking on higher what is that called, the abstraction level, that it's quite hard to explain what they are actually thinking anymore. So yeah, I would guess you can see a lot of that kind of teachers in Metropolia, especially on the field of technology. Remember that most of us are not actually first teachers and then the technology experts, but the other way around. So we first got our career on real life industry, and then became teacher after that. Yep. Okay. Speaking of the low-fi, I did the prototypes. Paper, pen, paper, scissors. Well, scissors you don't need necessarily. Little bit a fun exercise just for fun, but anyways, let's not play games. So never underestimate the power of pen and paper. You can do all sorts of stuff. A few years back, we had one of my colleagues was Juho Vesanen was working here. Now he's working for F-Secure as a some sort of specialist there, and he actually used a lot of this kind of, well, he had duct tape, and then not paper, but some of this Kapton, which is thin the plastic foam that you can bend in different shapes. He built a working prototype for a hydrocopter in 15 minutes using paper, the Kapton, not paper, the tape, that Kapton boards, and the knife, and of course the electronics. Lots of duct tape, but it flew. Okay, so same actually. It took half an hour to make the first prototype of hovercraft. It has a little bit more mechanical structures. But anyways, so pen, paper, scissors works just fine. Then basically you can start thinking of the ideas. In my case, I started with the wood since I have been carving wood since I was like 6 years old. I got my first carving knife before I got my first wristwatch. So basically I started just taking off extra wood and then thinking, how do I get the electronics in? Okay, let me drill some holes and stuff like that. The idea comes more clear, more tangible when you start working with, say, this kind of whatever you have around. Digital prototyping, same thing. So mock-ups with color and graphics, play around with those. So, okay, color and graphics. How do you create color and graphics if you have nothing else? Well, Paint.net works just fine for creating mock-ups for displays. And idea is still about the same. To find out if there are actually things that you can test. For example, web design. Which goes first? How do the art designers actually design web page layouts? Okay, they will start with pen and paper. I have seen it in practice. Um, yeah, okay. Then of course native prototyping, where you have the real devices and programming, but only if you have the fast prototyping tools. And that's the reason why Arduino is so popular. You can quickly design simple things that simple electronic devices that do some simple tasks. Although it's totally crappy system, but it works. Yeah, journey maps. So this is one sort of storyboarding actually. So simple storyboard, and this is actual the remote monitoring kit storyboard for I think it was for uh, for the use of people who are not healthcare professionals. So how to explain the customer how to use it. Storyboard is very simple way. Ah, have you bought IKEA furniture lately? Okay, yeah, storyboard works also as the instruction kind of thing. Yeah, and this gives quite nice idea when you take this idea IKEA the furniture. They always have this assembly instructions. That's basically a result of prototyping. They have done fast prototyping on how to assemble this. Yeah. Okay, more journey maps. So, yeah, this is some sort of, say, a timeline version of it. And then, well, this also, but it also has this kind of flow chart, the version of it. There are plenty of different ways to represent the whole the idea. And never underestimate the Legos. So how many of you have been playing with Legos? Yes, excellent. Me. The other ones, why didn't you use Legos? That's the perfect building block. I still like them. And they are used also on professional world. I have seen real professionals on the building. What is it? Civil engineering to design buildings using Lego blocks. Well, why the buildings look like square shape things? Lego blocks. Okay, but anyways, you can build amazing things with Legos. But anyways, they are on Lego. They also have this kind of academic kind of thing, and they take these games seriously. So learning is their business. It's not about making the blocks. It's about learning. Okay, so that's just a one journey map example, and then let's go to the serious play. Okay, this is used a lot on this, say, as a tool for social innovations. So instead of having storyboard, you can actually have a video of of something. How many of you actually? I cannot deny watching this Lego Ninjago and what is the other one? Star Wars, Lego Star Wars. Okay, think of that one. But now, seriously thinking, you can actually simulate or design the customer flow in department stores. For example, you have the department store layout, how to think of, okay, how people go there and how many of them you can actually put them on that certain amount of square meters. You start playing with Legos, with those characters. And yeah, it works. It's like playing dolls. Yep. So basically, it's if you forget the Legos for a while, then there's this desktop walkthrough. You can design people flow with that one. Okay. Uh, Hardware. How many of you have been doing some 3D modeling? 3D models, yeah, printing it out, yeah, it's fun. That's one of the easiest tools there, the Tinkercad. I have done a couple of those designs with the Tinkercad. Currently, I'm actually using the Fusion 360. By the way, it's Autodesk product, and as long as you are Metropolia students, you can have the Fusion 360 for academic price, which means 0. And that's a serious design tool. And this is more like the idea of that one is the same as on old-fashioned the mechanical workshop. So you take a piece of metal or some material and start forming it usually by drilling and then drilling, milling, carving or something like that. That's the design process. Then you can actually then translate that one into the 3D printer, as long as you remember the some things about the 3D print. So minus 45 degrees minimum angle. Okay. I will put that one as the exercise 4. Provide me a prototype at some form. Service prototype, for example, storyboard. Software prototype, use cases. Yes. Yes. The idea is not to make anything beautiful, but fast. Fast, quick, and dirty. Most, engineers do things quick and dirty. Then there's the ADs that do the case for the quick and dirty. Right. Engineers do the functionality, and then there are other people who are doing this so that someone could actually buy it. Okay. Digital wireframes, yes, there are also some tools, more hi-fi. Okay. So there's a task. Any questions on fast prototyping? I think I don't have. Yeah, I have got just a little bit of reading material, but that's it. Your prototype can be use cases. Do the design that way. You will thank me later. Maybe years from now, but you will thank me later. I'm quite sure of it. Okay, if you don't have any questions, then that's all for today. And welcome back next week at the same time at the noon. But week after that, there is no sessions, and then I will also take a look if we need any sessions further. Since now the pretty soon this project should go on the doing phase. Not yet, after. Okay, thank you.